The ultra-low frequency isolation withstand voltage test is a cathode power frequency withstand voltage test. It has been proved that use 0.1 Hz ultra-low frequency withstand voltage test is to replace the power frequency withstand voltage test. Not only can achieve the same equivalence, but also can greatly reduce the equipment size and weight. The theoretical capacity is about 1/5 of the power frequency capacity, and the operation is more simple. The instrument has a high degree of intelligence. It adopts digital frequency conversion technology, microcomputer control, and the test process such as voltage rise, voltage fall, and measurements are fully automatic. Multiple protections such as overvoltage protection, overcurrent protection at the high and the low voltage sides, and other multiple protection. High voltage currents and voltage data are directly obtained through sampling at high voltage sides, and the data are true and accurate. Now let's take an example with 60 kV VLF Hipot Test Set. Its maximum voltage can reach to 60 kV. Let's talk about the wiring first. The single output wire of the host is connected to the input wire of the booster. This wire is high voltage output wire and is connected to the test object and our cable. Please remember that this wire must be held in the air. The ground wire must be connected. Now, we are simulating the cable test. Use 3 PCAs, 30 kV, 2 microfarad series connected capacitors to simulate the cable. The high voltage output cable is connected to capacitor. At the other side of the capacitor is grounded. When the capacitance is less than 500 picofarads, we shall use the compensation capacitor to conduct the test. If we conduct the low-load boost test, the compensation capacitor also needs to be equipped, and the high-voltage output terminal is connected to our compensation capacitor. If the capacitance of the cable is larger than 500 picofarads, we shall directly connect the high-voltage terminal to the test object without connecting the compensation capacitor. The ground wire is connected and plugged into AC 224 power. After finish the wiring work, rotate the power switch to right side to turn on the equipment and enter the setting interface. First, we can set the voltage in the right side. Now we set it to 50 kV. The left side is the overvoltage protection. The default is 1.1 times of the target voltage. 50 kV multiplied by 1.1 is about 55 kV. The following side is the current overcurrent protection. Now we choose 30 mA, and now the default frequency is 0.1 Hz. Because it is a demo test, we set the time to 5 minutes. After the setting is completed, click Return. Now start the test directly. Let's explain the data here. The output V 30.8 kV in the right column is the actual output voltage. The following column 13.7 mA is the actual high voltage current, and 0.1 Hz is the test frequency. 50 kV is the target voltage, 30 mA is the overcurrent protection value, and 55 kV is the overvoltage protection value. The bottom side is the test time. The timing already started. It is 1 minute and 41 seconds long. Now the voltage has reached to 50 kV and it shows 49.9 kV here. When reaches to the preset end time, the test voltage will automatically drop and then the equipment starts up. Because it's just a demonstration, now we directly click stop to drop the voltage. Okay, the demonstration already finished, and we will need to use discharge rod to touch the test object for discharging. Then click the switch to close the equipment. And we will need to use discharge rod to touch the test object for discharging.